Now I'm changing the role from moderation to giving a talk to you. And what I will present in the following is some research I did for a monograph on the presence and the history of climate visualization, and it's a lot about data visualization. And 3 months ago, when we had to sketch out what we want to do, I was really fascinated by a very historical piece, so now we go back into history, into the year of 1800 and even before. And in the morning I already said that my method is to go back into history to learn about the presence, because, I quoted my colleague Jim Fleming, everything is unprecedented if you don't study history. And with my example, I would think that it's something what is still valid today. It's the very beginning of data visualization in the whole field, and it collides with climate research. So there's a map and a data visualization at the beginning of data visualization and climate research at the same time. And I want to talk about the data behind this map. So massive table work is at the center of a visual history of weather and climate. I look at early data collections of weather and how data was gathered and finally got visualized to form the first map of global climate change after 1800. And the standard history of metrology simply states that only after the year 1781, the possibility was given to draw such maps, respectively, to visualize climate. Before that time, instruments were neither good nor standardized enough, or the daily hours of measurements varied. In any case, it was impossible to compare the data because weather data wasn't robust enough. And this is how many historians framed the issue. But the question for me is getting more complicated if we abandon the perspective of technological progress and ask what took them so long, for example. Because there were over 30 years between the early publications of climate data and the foundation of the first weather networks institution, and then the realization of the climate map. And what I showed to you here, so this is here you see my slides in the following, is the piece of data I want to look at. It's a very early list of climate data collected by Alexander von Humboldt in the years 1816, which he published in 1817. And here he combined weather records from different places around the world, in the northern hemisphere, which he assessed to be robust enough for a statistical calculation of climate by that time. And this table, therefore, is the databasis for the visualization of averaged climate zones. And I show you the picture here. So this is the visualization of the data you have just seen. If we go into this map, you wouldn't even recognize it as a map, I think, in the first place. So again, we have this problem that where is Europe here? And you see the very line in the center, the vertical line, it's Paris. Because during this time, it was the meridian of zero, it went through Paris. And then you have 7 curvy lines, very beautifully geometrically shaped curved lines, and they show the climate zones. So they separate the world into 7 climate zones, the northern hemisphere. And to make it a little bit more simple for you, so this would be a later application of the isoline method, and below you see exactly the map behind the first climate map of Alexander von Humboldt. So, just a second. And what is interesting is that the list I just showed to you, it contains only 58 local weather measurements, the columns of the list. And some places have a length of 1 year only. Others, I think the greatest length is 10 years. And today, if you are in climate science, it's at least 30 years of measurements you need to talk about climate and make your statistical mean. But this wasn't what Humboldt had by this time. So compared to today's climate lists, consisting of thousands of weather stations and uncountable single measurements, which were collected over many decades. This number of 58 stands for a very wide meshed weather network of data by that time. And here, what I'm interested in is the history of table making, that is the production of structures consisting of lines and columns. At this point of history, a second medium comes into focus, and the table is a very powerful transit medium of data before data visualization. Without ordering data with the help of spreadsheets, data remains meaningless raw data. And we could think about the term raw here a little bit more. I was playing around with the terms raw and cooked data. I think the notion of raw is not that it's something that is very close to reality or pure data, or that it's the closest we can get, but it's more that it's, or undistorted, but raw more in the sense of unprocessed. So it's just the measurement somebody took. And then you could go on to cooked data, which would be statistical processed data. So this would be the status of this table. And if you want to go on with this metaphor, you even could think about surf data, and this would be visualization. And so my questions here are, how did the weather have to be framed in order to make climate visible? How was climate visually brought into being by processing these tables? When did questions of climate arise from the grid of the tabular weather spreadsheets? And why did researchers need decades to come up with the idea of visualization, to visualize climate in this way, and then, only then criticizing the limits of the tables, because you don't see very much in the tables. And here I go backwards to, now I wanted to show you one more image. This is an image I did together with a colleague. These are the measuring points, the weather stations behind the map you see above. So it's a really wide meshed network. I think today we wouldn't even give a line for the right side of this map, because there's only 2 weather stations. Still, the Humboldtian map is quite, if you would visualize it today from this data, you would get an image similar to this, what he did. So I wanted to talk about this very first visual metrological network, and this was founded by the Palatine Prince of Mannheim, Karl Theodor, in this year, 1781. So since then, there was a weather network with 39 stations he put together, and all over Europe and a little bit further. And it was called the Palatine Metrological Society, and they had a really interesting and interdisciplinary thinker as the head of this society, Johann Jakob Hemmer, and he organized this network, and it belonged to the Academy of Science. And they could have had even more stations, not only 39, but they had very strict rules for these observers, and they got many applications, but not all of them suited to these really strict expectations of the society. And what is also interesting, because they did publish all the data for many years, is that climate data until today is public data, and I think this is very important to know. And if you read the manual of Hemmer, how the strict expectations to be a good observer were given, here he exactly describes the instruments, most of them placed at the disposal by the society, like calibrated thermometers, barometers, hygrometers, but also some instruments the observers had to build by themselves, and also how to apply them in their observational spaces. And here we see how data are actually treated before they get notated in the table. And I would say they are handled like raw eggs. So he says, Hemmer writes, when one observes the thermometer, which is attached outside of the building, one has to take care that the quicksilver doesn't get heated by the candle or the breath of the observer. Observations have to take place 3 times a day at precise hours at 7 a.m., 2 and 9 p.m. Who is prevented, then he goes on, who is prevented of observing should ask a skillful neighbor to do the observation, although this is not within the meaning of the Palatine Society, quote end. So here we can think about the language of robust data and hard data and messy data in a different way, because I just imagine all these, if the observer was ill and then he had to ask his wife and she was getting the data at 7 a.m. and this must have happened in some case. But the grid of the tables of the Palatine Society, it's always, there's no, no blank space in it. So it's always there. Data is filled in. And I very much like the title image of the Palatine Society's observational journals. It's the lion, the power sitting on these tabular forms. And also the relation of data and power here is really interesting because the center of the network was the Mannheim station, and it was placed inside the castle. And here on top of it you see a model of the station. And now we could get into, I would like to simply try out what happens if we now look at a single datum, which then gets processed by Humboldt. And the Mannheim list is in Humboldt's image. It's there, the place Mannheim and the observational list. Humboldt used this list to calculate his statistical temperature mean. And we could, for example, jump into the year 1789 as an example in July and see what happened then. In July 1789, we can see cold temperatures and heavy rainfalls being noted in the table. It was a really very cold July in this year and lots of rain compared to the whole year. It would have been a first extreme, I think. And on the 28th, the 29th, and the 30th of July, this raining heavily was at all three observational times. And then there's an event related to this data, which cannot be read from this observation. Because on the 30th of July, the river Neckar flooded the city, and half of the city was covered by water, as this map shows. The castle, though, wasn't flooded because it was situated at the other side of the city. The story is not part of the weather archive. One has to look up, of course, a different archive, so this is something you wouldn't learn from the weather list. But I like to think of all the single moments of weather measurements 3 times a day as still being part of the climate list, and therefore the atmospheric conditions of the flood, in a way, are still part of the climate list, which was the basis for Humboldt's mean. The data changed its status to a homeopathically amount, but every single observation is still there. So such table work operations can be regarded as the technologies of describing the world and technologies of the archive. There were many effects of the early climate visualization realized by Humboldt and his successors. Observational data drew a distinctively different picture of climate zones than it was achieved through the pure mathematical speculation without data from observation. By processing and visualizing the weather data, therefore, climate as a scientific entity was visually brought into being. At the same time, there were many charges this early scheme, the table and the map together, brought up. The early visualization functioned as a concept for a method and practice which had to be continued, so to say, like a program forever, until today at least, and tomorrow also, in order to track weather and climate more precisely. And so to conclude, here we could talk about the bureaucratic materiality of such processes. For example, there evolves a very strong duty of the table. So the table has an agency, we might say. It serves the technosphere that commands to fill in the table like a letter case by the servants of the table, but also the implicit command of this method to maximize standardization on all levels, be it instruments, operations, and most important, time. And the servants then later got also called the Tabellenknechte, the servants of the table. And I think this is a beautiful picture of such a servant of the table, and maybe also the wife of the official observer, taking down the notes. And this picture is from one of the oldest German climate weather observatories in Hohenpeißenberg. And I just calculated that it's now running since 230 years. They are taking these values 3 times a day. So they have made since then 250,000 single observations to create this notion of the climate. And this also goes into climate research. So this is how the list went on. This is, if you look at the public data of Hohenpeißenberg today, I won't go into detail here, but of course it's not only temperature, it's much more. And today, most weather data are taken by machines, as you know. It's also a story of automation at 10,000 different places each day, 3 times. So to the present day, the connection between analytical graphics, trust in numbers, data and scientific knowledge, I would conclude, has not only persisted, it has actually intensified. And the method of data visualization functions as an epistemic and heuristic instrument of knowledge production, and it revealed climate change. So my last graph here is the combination of historical data, historical measurements, and the scenarios that are then calculated by climate models into the future. And I wanted to give an impression how the longue durée and the history of climate data observation comes together in these lists and visualizations. Thank you.